Okay, so basically we're taking the theorems that we already learned in 1.7 and we're looking at the converses of them. So apparently I messed up the packet that I gave out to you, so you're going to have to change yours to this. Clearly I did change it and made the copies of the wrong one, so I apologize for that. I think yours all say the same thing, right? Alternate interior or whatever it says. Okay, so you just need to change it so that you've got one that says same side interior angles postulate, one that says alternate interior angles theorem, one that says, oh, so I guess this one still is wrong. Okay, one that says alternate exterior angles theorem, exterior angles theorem, and one that says corresponding angles theorem. Okay, so you've got same side interior, alternate interior, alternate exterior, it doesn't matter what order, and corresponding. I'll change this last one maybe. It doesn't matter what order they're in. Okay, so if we look at the original theorem, for the same side interior angles, postulate, theorem, whatever, remember we kept the postulate so that we could prove the other theorems, but like I mentioned before, same side interior angles has been proven as a theorem in other ways, right? Sometimes people keep corresponding angles as the postulate and they prove this as the theorem. So at this point, we can kind of interchangeably call them theorems. So the original theorems, the hypothesis is the lines are parallel. If the lines are parallel, then. So we know the lines are parallel, right? So if the lines are parallel, then same side interior angles are what? Supplementary, right? This is the one that's supplementary. So if we write the converse of the same side interior angles postulate, what would it say? Yep. Good. Good. So if same side interior angles are supplementary, then the two lines are parallel. And we can do this with all of these, right? Write the converse of the alternate interior angles theorem. Well, what would it say? If what? So in every case of the original theorems, the hypothesis was if the lines are parallel. So in every case of the converse, what's the conclusion going to be? The lines are parallel. So we could add that in for all of these. The two lines are parallel. The two lines are parallel. Right? That's going to be the conclusion for every single one of these converses. So the hypothesis for the alternate interior angles theorem would be what? If what? Sophia? Good. If alternate interior angles are congruent, then the lines are parallel. If corresponding angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. So I'm going to show you a little demonstration with some meter sticks. Given the lines are parallel, you could make conclusions about the angles, right? That's what you've done so far. Well, now, this section is saying, turns out the converses are true as well. the converses are true as well. So if you aren't sure whether lines are parallel, and you want to prove that they are or they're not, then you can check to see if same side interior angles are supplementary or alternate interior angles are congruent to determine if the lines are parallel. Okay, so we're just kind of flipping the order here. All right, so if we look at this diagram, we've done stuff like this before, but it's an important skill because we are going to be taking these converses and writing proofs using them. We'll talk about that in a second. So you have to be able to keep straight what angles go with which lines. So which lines, if any, are parallel if angle 1 is congruent to angle 2. So now they're not telling us the lines are parallel. They're asking us, if we know that 1 is congruent to 2, what two lines could we determine are parallel? What two lines could we determine are parallel? Yeah, line A would be parallel to line B. So again, you might ask yourself, what's their transversal? Which is their transversal? M, right? So M can't be one of the parallel lines if it's their transversal. So that might be where you start. Let me see what line they have in common. That's the transversal, right? I know that can't be one of the parallel lines. So the lines must be A and B. Okay. What about which lines are parallel, if any, if 3 is congruent to 8? 3 and 8. Yeah, Erica. L and M would be parallel, and the transversal is A. Okay, what about 4 and 7? 4 and 7. Do 4 and 7 have a direct relationship? No, so we can't determine lines are parallel from 4 and 7 because they're not touching the same transversal. 7 is formed by B and M, and 4, was it 4? Yeah, is formed by L and A. So they don't have a line in common. Okay. All right, so if we keep looking down this page a little bit, look at number 2. Based on the following information, decide which lines are parallel and why. So if 1 is congruent to 5, which lines would be parallel? No, because that's the whole idea. This diagram is not drawn accurately so that you don't get any hints. You gotta just go by what the actual information given says. Yeah, Peter. Yes, M would be parallel to N. Good. What about 4 and 2? Also M and N. Good. And 3 and 7? Grant? 3 and 7. Nope. 3 and 7 are actually also M and N. And measure of angle 2 plus measure of angle 6 equals 180. If 2 plus 6 equal 180, that's PQ. Okay, so if we take that one, 2D, and we think about, thank you, if we think about this as being what we're trying to prove, let's say we're given this, and we're trying to prove this, right? So we're given that measure of angle 2 plus the measure of angle 6 equals 180. This we know, let's say that's given. And we want to prove that P is parallel to Q? Remember that an arrow pointing to this, P is parallel to Q, remember we said the arrows really mean like then or therefore. So this question is saying, what would this step have to be so that we can then say, therefore, P is parallel to Q? What would be in that step right there? Annabelle? Good. So what would be the reason for angle 2 being supplementary to angle 6? Definition of supplementary. Good. All right, so here is the question of the day. What would be the reason here for saying, therefore, since 2 is supplementary to 6, we can conclude that P is parallel to Q because, what reason? So same side interior angles, converse of. Okay, so you see the difference here? Same side interior angles theorem said if lines are parallel, then same side interior angles are supplementary. So our statement said, oh, these two angles are supplementary when we were using that theorem. Now our statement says, therefore lines are parallel. So this is where we're using converse of. Same side interior angles theorem. And you can use SSI for that. All right, so that's going to be the key to this lesson. When you are proving lines are parallel, and the statement says, therefore lines are parallel, your reason should always start with the word converse of. Okay? Does that make sense? Is that a hand up or no? Okay. All right, so when we look at number 4 then, if we're given that the lines are parallel in this one, you can pretend like this is a box that's pointing to the next box. These look like 2-column proofs, and you're used to flowchart proofs, but just think of it as the first box pointing to the second box. If L is parallel to M, and we're using this diagram here, what would be the reason for saying angle 2 is congruent to angle 6? Yep. But if we look at part B, now they're giving us that 4 is congruent to 5, and we're concluding that L is parallel to M. What would be the reason here? Exactly. So you have to think about 2 things now. What kind of angles are they? 4 and 5 are alternate interior angles, like you said. And you have to think about which way is this proof going? Am I proving lines parallel, or am I saying some conclusion about the angles? All right, so I'm going to have you just finish those up. Shouldn't take you too long. You can abbreviate. Pause. And when to use converse and when not to use converse. Do you guys see the difference there? Make sense? Any questions on that? Okay, so how is this going to change what our proofs look like? What might we be asked to do now? To do what? To prove that the lines are parallel. Right, so now our proofs are basically going to be proving that the lines are parallel. Sometimes they give you some lines are parallel and they want you to prove other lines are parallel. So it might be a combination of both things going on in your proofs. So let's do a few of these together, and then I'll let you practice them on your own, okay? All right, so let's look at this first one. This is more of a basic, right? 2 lines cut by 1 transversal, more of a basic proof here. They are giving us that angle 1 is supplementary to 7. 1 is supplementary to 7. Just don't want to mark them congruent, so I just marked them differently there. We're trying to prove that L is parallel to M. So remember this now. This is the tricky part. Because, you asked, well, can you make the diagrams look a little bit more like they actually are parallel, please? Because this looks nothing like they're okay, so this one looks like they are parallel, but they actually aren't giving us that they're parallel. It's not given. So now you're looking at this diagram. You cannot state that 1 is congruent to 6. You can't do it, because they didn't give us that the lines are parallel. In fact, these are supposed to be whited out, so pretend those aren't there. Right? If we don't know that the lines are parallel, we cannot use any of those relationships. I just crossed them out. They're not supposed to be there. Yep. Yes? Are you sure? Okay, so we do need, right, some other avenue to relate angles together. So we could use vertical angles theorem. We could use, what's our other choice? Linear pairs. These are our two old friends, right? Vertical angles and linear pairs. They don't have anything to do with parallel lines. So these are still fair game. So we have a couple of choices here. Does anybody want to suggest something? Okay, so let's start with our given. Good, that's good. Angle 1 is supplementary to angle 7 is given. And so now we've given the suggestion that we could say 7 is supplementary to angle 8 by the linear pair postulate. And that's okay. That's just something that we're concluding from our diagram. We're trying to get to say that L is parallel to M. We've pulled in an angle 8 here. Is there a conclusion we can make from what we have? 1 is supplementary to 7. 8 is supplementary to 7. Anna? Try that again. 1 is supplementary to 7, and 8 is also supplementary to 7. So what does that make 1 and 8? Congruent, right? So angle 1 is congruent to angle 8. Right? If you think of numbers, like let's pretend this is 100 degrees. This must be 80, right? Well, if 8 is supplementary to 7 and 1 is supplementary to 7, then 1 and 8 must both be 100 degrees, right? So it makes sense that they're congruent to each other. What's the reason? What's that reason, Claire? Good. Congruent supplements theorem. A lot of people were really resistant to this theorem when I was teaching it because they were like, well, I could just do it the other way. If you want to get your head around this theorem, it saves so much time and it will come up a lot. Okay, so congruent supplements theorem says 1 is congruent to 8. How does that help us in what we're trying to prove? What could we do now? Erica? Reason? Yeah. Converse of the alternate exterior angles theorem. Don't forget the word converse. Whenever you make a box that is a conclusion of lines being parallel, the reason will have the words converse of. All right, so let's see about the second proof here. They're giving us two pairs of parallel lines, and they want us to prove the third pair is parallel. So this first one says A is parallel to B, so they are giving us that. And then they're telling us that B is parallel to C. So we're trying to prove that A is parallel to C. It might seem obvious to you that A is parallel to C, but we're going to actually prove this officially. Yep. Okay. Yep. Okay, stop there for a second, please. Thank you. All right, good. Does everybody follow this? 1 is congruent to 2. What would be the reason there? If A is parallel to B, she's saying 1 has to be congruent to 2. Why? Yep, corresponding angles theorem. And she's saying if B is parallel to C, 2 must be congruent to 3. So also corresponding angles theorem. So therefore, 1 must be congruent to 3 by the transitive property of congruence. I would just like to restate the fact that there's no such thing as the substitution property of congruence. There is no such thing as substituting with congruent symbols. Some of you are still trying to use substitution in this case. And then I've seen people where they have an equation and they've replaced one thing and they're calling that transitive. So you're getting a little bit confused between transitive and substitution. But this is the transitive property of congruence because we have all congruent symbols. So what? 1 is congruent to 3. How does that help us say that A is parallel to C? What is going to be our reason? Emil? Converse of what? Nope, there's no. Good. Converse of the corresponding angles theorem. So since 1 is congruent to 3, that makes A parallel to C by the converse of the corresponding angles theorem. Incidentally, this is basically the proof of the I guess I'm not sure exactly what it's called, whether it's called a theorem or whatever, but there is a theorem that basically is the transitive parallel theorem. and it actually works, right? If A is parallel to B and B is parallel to C, then A has to be parallel to C. Doesn't that sound like transitive property? We don't have a transitive property of parallelness, but there is a theorem, I forget exactly what it's called, but it's basically, we just wrote the proof of it. So it's I'll look it up. It's a transitive parallel theorem, which is what you were kind of hinting at on your homework, right? Did I hand you back your homework? Look at the back of your homework. Okay. Right. All right. So let's look at one that's a little bit more involved, like this one, number 4. Okay. So given that L is parallel to M, so we know that these two are parallel. We're trying to prove that A is parallel to B. This is where you really have to keep straight what you know and what you don't know. So what you know and what you're trying to prove. So again, this might be a time when you use colored pencils to kind of color code things that are established as being parallel. So I know the red ones are parallel. I don't know anything else about A and B. I also know that the measure of angle 12 equals the measure of angle 8. Now, are 12 and 8 directly related in some way we can put a name to? No. However, is there a linking angle that would somehow relate 12 and 8? Is there a linking angle? Mason? An angle that relates to 12 that also relates to 8. All right, how does angle 1 relate to 12? Good, and how does 1 relate to 8? Also alternate exterior, right, in a different direction. Okay, based on, let's use angle 1 since that's the one that came out. There are others that you could use. Based on 1 that has a relationship to 12 and a relationship to 8, which one of those two relationships can we actually state exists right now? Okay, with 12. So L is parallel to M is given. We can state that angle 1 is congruent to angle 12. By the, what reason? Alternate exterior angles theorem. Is this a converse? No. We were given that the lines were parallel. We're saying the alternate exterior angles are congruent. Let's look at our other given. Since we're dealing with since we're dealing with congruence signs, we should probably switch this into a congruence. So what conclusion could we make then? If 1 is congruent to 12 and 12 is congruent to 8, what conclusion could we make? Alan? Good. Well, now, if 1 is congruent to 8, now what conclusion can we make? So what conclusion could we make here? Peter? Not congruent. Parallel, and what's the reason? Perfect. Yep. Converse of alternate exterior angles theorem. Okay, so do you see how important it is to establish what you know and only make relationships in that direction? So since we knew that these two red lines were parallel, we could only make relationships between these two, right? We couldn't go from here to here because we didn't know the lines were parallel. So the only relationships we really could establish given to us were between those two sets of 4, right? Then we linked it to the other way. So every time you're trying to prove lines parallel, the step before it should be some box with a statement about some angles. Angles congruent, angles supplementary, whatever it is, there should be some established relationship that you establish some other way that gets you that relationship to then be able to say lines are parallel. I have seen people, you know, put alternate exterior angles theorem here, and then converse of alternate exterior angles theorem here. That doesn't work. So, I mean, there's a rare occasion where those two things will follow each other, but if you are writing a proof and that comes one right after the other, like alternate interior angles theorem, converse of alternate interior angles theorem, double check, because you might be assuming lines are parallel when they're really not. Okay, so I'm going to have you practice a little bit on your own.